So with limits, when you're calculating a limit of a function, usually what works, and this is with most functions that you can just write down, usually what works is you just plug in the final value. So like if you're taking the limit as x approaches a, then you just try to plug in an a into this function here. And that's usually gonna do it. Well, for most functions, that's usually gonna do it. But there are some places where the functions, some things in cases where the function is not defined, in which case it doesn't, and we'll get to that in a little bit. But all these rules pretty much hold over, and then also rational functions and polynomials, you just plug in the number. That's what this section's all about. Just plug in the number for any polynomial. Just plug in the number. Just plug in the a to find the limit. For any rational function, just plug in the a to find the limit, unless the denominator, plugging in the a gives you a 0 in the denominator. And then there's a few ways that you need to do to handle that. Okay, so let's go and get through some exercises here. Put that into place. So this first one is just straightforward application of the rules that we saw on the other page. So the limit is x approaches 2 of f of x plus 3 g of x. That's just going to be, well, the limit, this f1 is 4, and the limit, so that's a 4 there, and then plus 3 times whatever the g limit is, and that's -2. Okay, so that's going to be 4 minus 6, which is going to be -2. So basically just plugging in the values there. Okay, and then the second one, you're taking limit of x approaches 2 of g of x to the third. So you just plug in the limit of g of x, which is this one. You just plug that in there, and that's going to be -8. Okay, and then this next one is the square root of limit of x approaches 2 of the square root of f of x. So that's just going to be the square root of 4. Okay, because that gives you a 4 right there. So that's just going to be 2. And so on, proceed as so on. Okay, so this one's a quotient. So it's 5, and then the f of x limit is 4, and the g of x limit is -2. So that works out to be -10. Okay, and then this next one, the g limit is -2, and the h limit is 0. So that's true divided by 0. So this one you enter in DNE, which stands for does not exist. And then this last one, the g limit times the h limit, so that's the -2 times 0 over the f limit, 4, and that's going to be 0. Okay, now you also have to pay attention to one thing here, and let me just circle that these limits are going to 2. Okay, so if it's going to a different number, then you have to pay attention to that right there. Okay, that they're all going to 2. So then that means you can just plug that stuff in. If it's going to, you could have a situation where they're going to different numbers, and then things would be different. Okay, so here's some graphs, and we'll go ahead and try to figure this out from the graphs. So here we have the graph of f, and here we have the graph of g. Okay, and for a, we're supposed to find the limit as x approaches 2 of f of x plus g of x. Okay, so 2 is, let's see here. This is the y-axis. This is 1. This is 2. So 2 is right there, and then over here it's right here. Okay, so now as you're approaching 2, f is going to -1. Okay. Okay, so this right here is -1 right there. It's got a hole there, but that's okay. The limit does not depend on what the value is at the point. It just as it approaches that point, what is it going to? And it's going to -1. Okay, it's going to -1. Here, as you go to 2, you're going up to 2. This is 2. You're going to 2. So that's 2. Okay, so that's just going to be 1. So adding those two together. Okay, next one, we got the limit as x approaches 0 of f of x minus g of x. Okay, so 0 is right here and right here. You can tell because it says y-axis, and that's where 0 is. Okay, so over here, you're going to 2. Okay, this is 2. So the function is going to 2. So that's 2. And then over here, from the right, it's going to 1, and from the left, it's going to 3. So this one is does not exist. The g limit doesn't exist. So that means that the whole thing's not going to exist. Okay? And that would be the answer. It does not exist. Okay, for part C, we're going to -1. Okay, and so here's -1. And f is going to 1. Okay, so that's 1. G is going to 2. This is 2. So that's just going to be 2. Okay, and then here we're going to this part D, we're going to 3. Okay, and so 3 is right there. So that's what you look for. You look for the 3 there. And F is going to 1. So that's 1. And G is going to 0. Well, so it's 1 divided by 0. So that one also does not exist. Okay, and then this one's going to 2. Okay, we already have 2 there. So, but they put this x squared in there. So you just plug the 2 into the in for x, like that. That's how you handle the polynomials. Just plug in the x value there. And almost any function that you can write down, that's how you do it. Okay, and then f of x is going to -1. Okay, so that's -1. So that's going to give you -4. And then this one is f of -1. Okay, so this is f of -1, and that is, here's f. Here's f. Here's -1, and it's way up here. Okay, so this is 3. So f of -1 is actually 3 because it's up there. The limit as you approach -1 is going to be 1 because that's right here, because that's approaching this value here, this 1 here. Okay, the limit as x approaches -1 of g of x is going to be 2. That's +2. So that's going to be 5. Okay, any questions about that? Okay, let's move on to the next one. So generally, like I said, to evaluate these kind of limits, you just plug in the 2. But unfortunately, when you plug in 2, you get, no, it's fine, you're fine. Just plug in a 2. You get, erase that. This one's fine. So you get 2, in the numerator, you get 2 squared minus 8. Okay, and in the denominator, you get 2. I like to put parentheses around whatever I plug in. That makes it a little clearer what's going on. Okay, so that's 4 minus 8, that's -4 up there. It's not going to be squared. This is 8. 8 minus 12 is -4 plus 7 is 3. Okay, so you square that, it's going to be 16. What? 16 over 9. Okay, so that should be the answer there. Okay, moving along to the next one. This brings up an important point, which is how you handle, this is kind of getting into how you handle something like this, okay? So what happens is x squared plus x minus 30, it factors into x minus 5 and x plus 6, right? So this expression is actually equal to this expression here. Those are equal for sure. And then canceling off the x minus 5s gives you x plus 6. Okay, and so like what? So people, because a lot of people would be like, whoa, that's nothing wrong with that. You're just canceling off those guys, and which is what the high school teacher told us to do. And that's fine and all, but the problem is that is this right here. The left-hand side is not defined. So this is not defined when x is 5. You can't, if you plug a 5 in here, yeah, you get 0, but you get 0 in the denominator. You get 0 in the denominator. You can't have 0 in the denominator and be defined. So this is not defined. But you can plug a 5 in here and you're fine. Okay? So essentially, if you were to graph this, function right here, that function, what you would have is, it would basically be a line. There'd be 6. So this is basically y equals x plus 6, right? That's a line. The slope is 1, and the y-intercept is 6. Okay, so it's going to be like that. But when you get to 5, it's going to have a hole in the graph. Okay, it's going to have a hole because it's not defined right there. So it's going to be this line with a hole right there. Okay, so the left side is not defined, but the right-hand side is at 5. Okay, over here, this is correct because the limit does not depend on what the value at the point is. Yeah. Since the equation holds for all x not equal to 5, it follows that both sides approach the same limit as x approaches 5. So that would be that one right there. Okay, any questions so far with that? Okay, let's go to the next one. And that kind of gives us an idea of how to handle these next ones. So here, it turns out that if you plug a -8 in, you get a 0 in the denominator, I think. Yeah. But you also get a 0 in the numerator. Okay, so what you're going to do is you factor the numerator. That's t minus 8 times t plus 8. And you factor the denominator. That's 2t. And then we have a t minus 8. And we have a t minus, no, t plus 8. And 2t plus 1. Yeah, that does it. That works. Okay, and then these ones reduce off. Okay, because we're taking the limit as like as t goes to -8, so it doesn't matter what the value is at -8. And that means you can just plug in -8 here. And plug in a -8 here, which is going to be -16 over -15. Okay, so 16 over 15 as the answer. Okay, number 6, evaluate this limit if it exists. Okay, here, let me just show you something will happen. If you plug in 0, then you're going to get the square root of 64 minus 8 over 0. So you get 0 over 0, okay? So that's not going to get you anywhere. So what you do, or what you can do, there could be other ways of, there's other ways of doing this, for sure. But this is probably the best one for you guys to look at right now. And that is, you take this expression and you multiply by a fancy form of 1, which will be this right here. And that's going to be the square root of 64 plus h plus 8 over the square root of 64 plus h plus 8. Okay, so this is this divided by itself, so it's a fancy form of 1. It's 1. It reduces to 1, right? So you can multiply anything by 1 and you still get the same value, right? Okay, and then the numerator, because this is sort of conjugates, what you've got like a minus b times a plus b. So you get a squared, which is just 64 plus h. So the square root of 64 plus h squared is just 64 plus h. Okay. And then minus 8 squared, which is 64. So that's what you get in the numerator. The denominator is just, we'll just leave the denominator alone. Like that. Then the 64s are going to cancel. And then you're just left with an h, right? And that's just going to reduce with this one, reduce to 1. Okay, so what you've got is the limit as h approaches 0 of 1 over the square root of 64 plus h plus h. And so then here you can plug a 0 in. And that's 1 over 16. So our square root of 64 is 8, and then 8 plus 8 is 16. So okay, so 1 over 16 for that answer.
Wait, why does the, can you explain again, why does the h, like, why do we get like square root of 64, and why did the h like disappear?
Right here?
Because it's 0?
Yes, I plug in a 0 for 8.
Okay, yeah, I got it now.
Okay, great. Thanks for asking. Okay, number 7. Okay, so here, if you plug in 36s here, you get, so 6 minus the square root of 36 over 36 times 36 minus 36 squared. Well, that's going to be 0 over 0 again. Okay, so plugging in is not going to give it to you. But there's hope because there's a 0 up here, so maybe this 0 would cancel with the one down there and it would be something else. Okay, so let's go ahead and so what we can do here. The denominator factors into, you can factor an x out. And you have 36 minus x, right? That's just factoring x out. Okay, now you can factor the denominator further. It's kind of weird, but this guy here will factor into, because you have the square root of 36 is 6, and the square root of x is the square root of x, right? So it'll factor into 6 minus the square root of x times 6 plus the square root of x. Okay, now normally you wouldn't do that, but you have a 6 minus the square root of x up here, and so, you know, why not? Okay, and then these are going to reduce. This reduces to a 1 up here. Okay, so you get the limit as x approaches 36 of 1 over x times 6 plus the square root of x. Okay, and then here you just plug in this 36 into here and there. So that's 1 over 36, and then this is 6 plus, this is 6, so 6 plus 6 is 12. And that's 1 over 432 when you multiply those together. Okay, number 8 is a principle that we call the sandwich theorem. So so if you look at this one, as x goes to 1, this goes to 8, right? And this one, all this, as x goes to 1, you get 4, except you're plugging a 1 here and a 1 there. So that's 4 minus 4 plus 8. That's also going to be 8. Okay, so those both go to 8. So that means this has to go to 8 as well. Let me try to illustrate this a little bit. I'm not going to like do a really great graph of this, but look at it this way. So here's y equals 8 of 8x, right? Okay, so y equals 8x, that would be this one right here. Okay, and that's going to be a line. The slope's going to be 8, and the y-intercept is 0. Okay, so that's like that. Okay, now let's say that 1 is about right here. Now apparently, this one right here is above that. Okay, now I'm not going to take the time to graph that nicely, but it does go through this point right here. So maybe it's something like this. Maybe, who knows? Right there. Okay, and now it's saying the problem is saying that this G, we don't know what G is, but we know that it's between here and here. So it's got to be between here and here, and then here it's between the purple one and the blue one. Okay, so G kind of has to come down through here. It could like do weird stuff. I mean, it could be like this, but eventually it's got to go to that. So it's going to 8. Okay, so it's sandwiched in between the blue, the 8x, and this one. It's sandwiched in between. We don't know what it is, but it's sandwiched in between them, and so it's got to go to. It's going to go to 8. Okay. Any questions about any of that? Okay, let's move on. Number 9. Okay, now this is something that's sort of along those lines, but maybe not quite. Okay, so here, if you try to plug a 0 in, that's not going to work. You have 5 over 0, that's undefined, right? So you can't plug that in. But cosine, okay, so the way to approach this one is as x goes to 0, 5 over x, well, as you come in from the, okay, so there's two things. As you come in from the right, it goes to infinity. But as you come in from the left, it goes to negative infinity. Okay, just the 5 over x. Okay. But another thing that you might notice is that cosine of 5 over x, it's always between -1 and 1. Okay. So as x goes to 0, yeah, these both go to infinity, but they're always between -1 and 1. And then the meanwhile, x to the 6th goes to 0. Okay, as x goes to 0, you plug a 0 in here, it's going to 0. Okay, so basically, this is the way to think about it, maybe, is that this, in the end, you're going to get like 0 times something between -1 and 1. And so that's going to, so then the answer is going to be, it's just going to end up being 0 is the answer. Even though this one just kind of fluctuates, it just kind of bounces between -1 and 1. This part causes it to go to 0. Okay, so because of this right here, and then this one just can't make up their mind. Okay. Number 10. Okay, so here, the numerator is, you can factor an 8 out of the numerator, and that gives you x plus 5, right? And you're dividing by the absolute value of x plus 5. Okay, so if you take the limit as x approaches -5 from the right, okay, so from the right, okay, from the right, that means, this means that x is, you're going through values that are greater than -5. Okay, and that means that x plus 5 is greater than 0. Okay, so if you add so this plus means you're going through values that are greater than 5 and coming down to 5, which means that x plus 5 is great when you're coming from the right, x plus 5 is greater than 0. Okay, and the absolute value of x, it is equal to x if x is greater than 0 or equal to 0, and it's equal to -x if x is less than 0. Okay, so that means that this denominator is x plus 5. And then those will reduce to 1, and that's going to give you 8. Okay. On the other hand, if you go the limit as x approaches -5 from the x approaches -5 from the left, okay, as you're coming in from the left, that means x is less than -5. So you're coming through values that are less than -5. And that means that x plus 5 is less than 0. Okay, which means you're going to go with this option right here for the denominator. and you're going to have the negative of x plus 5 in the denominator. Okay, so those reduce, but you get a negative 8. Okay, so coming from the right, you get this is 8. Coming from the left, it's negative 8. That means since these are not equal, that means the limit, it does not exist. Okay, so because these both have to be equal for the limit to be able to exist. Okay, so any questions about that? Okay, let's go to number 11. And find the following limit. So it's the limit as x approaches 1 from the left. Okay, that means that for this one, you're going to use this one, because this is left means, from the left means x is less than 1. So just plug in that value. Just plug in a 1 into here. That's going to be 5. Okay, here you're coming from the right. So that means you're going here. This part right here means from the right. Okay, and this means from the left. Well, sort of. Okay, so you just plug in a 1 into here. And that's going to give you negative 1 squared, which is 1. And so because those are not equal, that means that this limit doesn't exist, does not exist. Okay, because it's 5 from the left and 1 from the right, so it does not exist. Okay, and then finally, we want to sketch the graph. Okay, here, this is a parabola that opens up. Vertex up here at 4. Let's see, let's say that's 1 right there. So it's going to open up like this. So it's just a parabola that opens up like that. Oh, dang it. Okay, and there's a hole right there because this is not defined, because this is the greater than or equal to. This one has the equal to part, and this one. Okay, this one is a parabola that opens up. Its vertex is right here at 2. Dang it, I'm so bad at drawing. Okay, but the thing is right here, and it's going to open up like that.